Okay. Yan to. Excuse me a while now. I have to check something. Okay, good morning everyone. I'm sorry for the disturbance na. Kabuga. Hindi na kabuga. Okay, anyone else?
Good morning po, Sir Chavez po, sir.
I'm sorry for the disturbance na. There's a disturbance outside. Chavez, okay. Anyone else? Do you have anyone else? Suarez,
Mercado, sir.
Mercado and Suarez.
Yanto, sir, present.
Come again?
Yanto, present.
Yanto. Yes, I think I've checked.
Kabuga, sir.
Come again?
Kabuga.
B?
Kabuga.
Kabuga, yes, I've checked. I've checked Kabuga, okay.
Simon po, sir.
Simon, yes. Simon, yes. Simon. Ay, ito pala, no? Sorry, no? Si Simon ang hindi ko na-checkan. Sensano, are you there? Sensano? I think mali na. Narca? Navarez, are you there? So, the exam is still there, no? The exam is still up. You can still take the exam. Those who haven't need to take. I have emailed you the password. Okay, so you can take the exam. I think it's still up until today, no? Okay. So please try to get some more attempts if you want to improve your grades. No? As long as you pass, there's no problem. No? Beyond passing will not affect your final grade anyway. No? So last meeting we have discussed the arithmetic and conversion of floating point and fixed point representation of numbers. No? And then I've given you 3 methods, and I have given you sample exercises, and I've answered the practice exercise. No? So today we will have a new lesson. Okay. Now this will be the last lesson before our second formative test, which will be about the 3rd week of November. Do you follow? So it must be on the 7th, dito sa 17 to the 20th. Okay, we will have our second formative test involving numeric representation and binary conversion. Okay, do you follow? Do you follow? Okay. Okay. Any questions so far? So second formative test, no? Maybe I'll just open this na lang so everyone can see. This is ready anyway, no? Will be on 17 to the ano na lang. Let's make it, let's schedule it on a weekend. From 17 to 20. Okay. I think that's time enough, no? To 20 at 12 p.m. because the first class will start at 1:30. Okay, you have any problems with that? I don't think, no? It's still more than a week away from now, okay? This is the second formative test. We will open this on the 17th, and we will close this on the 20th. Okay. 8 a.m. to 12 p.m. Okay. And then attempts allowed will still be 3 attempts. Okay. And then review options, whether correct immediately after the attempt, marks, I can give you marks, no? But the right answer, hindi pa pwede, no? Okay, you can get everything. Later, while the quiz is still open, the attempt marks, no? You can get your marks after the quiz is closed, no? Okay. Any questions so far? No? Sorry, no. Sorry for the disturbance again, no. That will be the last, I hope. Okay. Anyway, the coverage will be the representation and subtraction. This will be our last topic on subtraction, okay, on binary numbers. Okay, you can download the slide. No, there's a subtraction of binary numbers, fractions, even involving fractions. And then there's also a practice test. No, sample exercise in binary subtraction. We will answer this next meeting. Okay, I'd like you to take this because we will answer this next meeting. Okay, and now I'm going to show this. Okay. And then you pass your solutions in Excel, no? Okay, for second formative test, no? This will be due on until September 20th, no? So what you do is solve the answers, solve the quiz, and pass your Excel solution separately as an assignment. Okay, do you follow? Do you follow? We edit the settings. September, this will be September 17 to September 20. 12. This will also be at 8. Okay. The cutoff date is September 20. Okay. We'll make this later. Okay. All your Excel solutions, please pass them with your last names first, no? Indicating that anyway, I will get the file as soon as you have uploaded it. Okay. Any questions so far? That's how you answer the test, the second formative test. Okay. So for the moment, let us open the PowerPoint slide, which you can download. No, it's on binary subtraction involving negative numbers. Okay, subtraction of binary numbers and representation of negative values. Okay. Okay. Any questions? So this is the last topic before the second formative test. Subtraction of binary numbers. You have dealt with addition. Okay. So the main difference between binary addition and binary subtraction is when one is added to one, it equals 0. And we carry a 1 to the next. No? In case of binary subtraction, when you say 1 is subtracted from 0, it's not enough. So we do a borrow. Just like when you subtract in decimal, no? When you subtract a bigger number from a smaller number, you have to borrow 10 from the next most significant digit. So we have to, there's no other borrow here. No? We can only borrow 1. Okay, from the next order digit and get the remainder as 1. Okay, for example, the particular arithmetic is like this. Okay, 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 1 is 0, of course, we know. And 0 minus 1 is 1 with a borrow of 1 from the next. The borrow of 1 actually is a borrow of 2 because the next digit is a 2. So 0 minus 1 is actually a 2 minus 1. That's why it's 1. Do you follow? Okay. Any questions so far? Okay. To understand, now the problem with subtraction is if you do this manually, it's like a different process from addition. And most calculators do not use a separate process because it will involve a different circuit. No? So involving a different circuit will complicate the machine itself, the electronics itself. So therefore, people are trying to make use of addition in order to do subtraction. Now the question is, can we do subtraction using the addition process? For binary numbers, yes. Do you follow? We can subtract by using addition. Okay. First, what we do is convert the negative number into a suitable form. It's called a 2's complement form. Okay. Any question? But before you can convert into 2's complement, you have to place it into 1's complement first. Okay. What is 1's complement? Now, we know that binary numbers comes in power of 2's. No? Numbers in 1's complement are pairs. Do you follow? They're like boyfriends and girlfriends, husbands and wives. Pairs, they are pairs. Okay? Such that when the pair is added together, they will equal a fixed value equal to the next power of 2. The maximum value of the next, rather to the sum of the next power of 2. So to understand it further, let me explain two important properties, no, of binary numbers. Given n bits, n is the number of bits, an n-bit binary number, the maximum value is 2 raised to the n subtracted with 1. Okay. For example, if n is 4, the maximum value is 1111. That is 2 to the 4 minus 1. So 2 to the 4 is 16 minus 1, 15. Okay. So if n is 4, the maximum value is 15. Okay. If n is 5, the maximum value is 31. Okay. If n is 6, the maximum value is 63. Okay. Because it's 64 minus 1. Okay. Now, in terms of the most significant bit, okay, the most significant bit here is n, this bit. No? The most significant bit has a value of 2 raised to the quantity n minus 1. No? Quantity muna. Okay? And use it as an exponent. For example, for 4-bit numbers, the MSB will have 2 to the third or 8. So this is the highest place value here is 8. Okay. Any questions so far? No. 1's complement. Given an n-bit numbers. Now, 1's complement, x and y are 1's complement, which means they are pairs, like boyfriends and girlfriends. No? And so sometimes one boyfriend can have several girlfriends. But in this case, 1's complement only comes strictly in pairs. No? Hindi pwedeng maraming girlfriends. Okay? We know that x and y and even girlfriends can have, no, also a lot of boyfriends. No? X plus y are 1's complement if x plus y is 2 to the n minus 1. Okay, where n is the number of bits composing x and y. For example, for 4-bit numbers, no, if you are given a value, the maximum value, no, so the maximum value for n bits. If you are given a value 1010, what is the 1's complement? Okay, we know that for 4 bits, the maximum value is 15, right? The maximum value is 15. And we know that 1010 is 10. Okay, so we get the maximum value minus 10, which is 5. Okay, 5 is the 1's complement of 10, and they are pairs. Why? Because 10 plus 5 is 15. So they will equal the maximum value given that n-bit series. Do you follow? So pairs talaga yan. Like 10 and 5, what can you have? 11 and 4, no? 9 and 6, okay? 7 and 8, okay? Do you follow? They are 1's complements. Now for the next power of 2, for example, for 32, no? Next, which is the next power of 2, 30 and 1 are 1's complement. Okay? 16 and 15 are 1's complement. Because when you add them together, they equal to the maximum number of the next power of 2. Do you follow? No? Do you follow? So take note, if you have 10, the value of 10 in binary is 1010. And the value of 5 is 0101. One another characteristic, aside from the sum, no, of the complement, is the flipping, no, of zeros to ones and ones to zeros. If 10 is 1010 and 5 is 0101, we can say that if two numbers are 1's complement, they are flips. No? You can convert a number to ones complement by flipping zeros to ones and ones to zeros. Okay? Okay? Any questions? So that's another way. That's a short way of computing, no? Okay, ones complement. For example, no? What's the ones complement of 127? Because 128 is the next power of 2, right? 128 is the next power of 2. The maximum value for that is 127 minus 1. So what is the ones complement of 123? We subtract it from 127, which is the next power of 2. 4. So 4 is the ones complement of 123. If you look at that, no, 123 is 1111011. Okay, 4 is 0000100, which actually also a flipping of zeros and ones. Okay. Any questions so far? You must understand that property in order to be able to understand subtraction. Ones complement. Okay, ones complement. No. How about for fractions? Incidentally, no, the same property applies. For example, okay, if you have the value 0.111, okay, the actual value is 0.875 because that's 0.5 plus 0.25 plus 0.125, 0.875. Okay. For example, no, the ones complement of 0.625, you find that out, no? The next value is 0.875. You subtract 0.625, you get the ones complement. Okay. For example, 0.625 is 0.101, right? Because we know that to be 0.5 plus 0.125. Okay. If you subtract 0.875 with 0.675, you will have 0.25 or 1/4. That's also 0.010. So take note, it's also a flipping of zeros and ones. Okay. Any questions so far? No. The twos complement of a binary number is the ones complement plus 1. Okay. Now, it's a continuous process. If you continue it, it will go back to the original form. For example, the twos complement of 101 is ones complement plus 1. Diba? So you flip the ones, you add 1, you will have 010. But if you do the same process to 010, you will have 010, you flip it to ones, add 1, you'll go back to the original form, which is 101. Do you follow? That's the main characteristic of twos complement. Now, twos complement is important because twos complement converts a number into its negative form. Do you follow? So, in order to do subtraction by addition, we convert the subtrahend. No? Minuend subtrahend. The subtrahend is the negative number, right? We convert the subtrahend into twos complement and we perform addition. Do you follow? No? So subtraction in binary is just addition using negative numbers. It's the same process. Okay, any questions so far? So you have a table of twos complement and ones complement, no? If in case you want to memorize, but you can convert them easily yourself. Okay. So how about the twos complement of binary fractions? When you use binary fractions, you use the least significant bit. No, there's no compromise to this because the leading and trailing zeros are important in twos complement because you have reversed them from 1 to 0 and 0 to 1. So the leading zero are important, the leading zeros. The trailing zeros are also important. No? They follow? You do not erase them when you use twos complement. Okay? For example, find the twos complement of 123.75. So this is 123.75 is like this. 1111011.11. Okay? 0.75. It's 0.5 plus 0.25. You convert to ones complement. So 001 00 plus you add a 1 to the least significant bit. Take note to the least significant bit. Okay? So 0 plus 1 is 1, 0 plus 0 is 0. And this is the twos complement of negative fractions. Okay? Now there's a formula to convert. No? There's an exercise in Baker which you need to do. No? To convert a formula. Okay? Converting an n-bit twos complement integer to decimal. How do you convert it back? Okay? For example, if you know that number is in twos complement, for example, this number, you know that is in twos complement. There's a quick way to do that. You don't have to reverse and then convert to ones complement. No, that's a tedious process. What you do is apply the same method that you do before, but check the most significant bit first. No? If the most significant bit is a 1, you just do ordinary computation assigning a negative place value to the MSB, most significant bit. For example, if you have 11011, normally you will assign 168021, right? So since the most significant bit is a 1, you assign it a negative 16. Okay? Negative 16 plus 8 plus 0 plus 2 plus 1, this is a negative 5. Okay? If you try to convert it using one's complement, it will result to the same process. I don't want to show that now because this is an established theory. No? For example, if you have 0, 1, 1, 1, 1, it starts with a 0. You extend it further and you add a 1 to the next. And then you do the same by assigning a negative value to the most significant bit. So if you have this number, the actual value is negative 17 because it's negative 32 plus 0 plus 8 plus 4 plus 2 plus 1. That's negative 17. Okay. Now, for the moment, if you look at our regular site, there's a very good video there explaining negative numbers. I'm going to do the example using that video. No, the examples used in that video. Okay. Dito itong video na ito is by an Indian, by a very popular YouTuber. I'd like you to take a look at this because it's very well explained. There are a lot of good sources from YouTube, but this one is very well explained and it's good enough because it also involves fractions. The main problem with other sources is they do not involve fractions. Okay. Okay. I'd like you to look at this, no? Subtraction using 2's complement, okay? So,
The last mile 99 big red.
okay. So, ito yung examples niya. Okay. I suggest you do this in full screen. Okay. This is the example of, no? The example is 26 minus 25, 25 minus 26, and 11.25 minus 6.5. I'll do the same, okay? Okay, do you follow? Okay, let's pause this and then let's do ourselves. Let's do this ourselves. I don't want to show the Excel because what I'd like you to do is do the computation again. Okay, okay. This is simple, no? Very self-explanatory. You must be able to do this yourself. No? So what we need to do is 26 minus 25 first. Okay. So we compute 26 minus 25. Okay. Okay. Are you ready, everyone? We'll do 26. What will we do is we convert 26 now first. And then we convert 25 to 2's complement and we do addition. Okay? So if you have 26, can we have 64 na lang? We start at 64. 32. 16. We have 8, 4, 2, 1. Okay? This is our binary series. No? We're just doing addition here, so we'll use the same, we'll use the same sheet, no? Equals this divided by 2. Equals this divided by 2. Likewise, we'll end up to the 6th binary place. Ilan na tayo? 1, 2, 3, 4. Okay. Any questions with this? I hope you're familiar with this already, right? Okay. Why is this like that? Because this is a 1/2. This is a 1/4. This is a 1/8. 1/8. And this is, I'm sorry, what happened to that? This is a 1/16. This is a 1/32. This is a 1/64. Okay. This is just tedious at the start, no? Pero later on, we'll just copy and paste anyway, no? Madali na lang. I'll just center this. Okay, do you follow? Okay. What is 26? We'll have 26. Then we'll have this. Pick and mark pa rin tayo, no? Still have a pick and mark, no? And then we'll sum this. Okay. Dito natin ilagay ang 26. And then we'll subtract. Okay. And then we'll bold this so that you can see this better, and then we'll color it red. Okay. So for 26, we will have 116. Okay, we have 16. We have 10 left, so we'll have 1/8, and we have no 0, and we will have one of this, and we have a 0 in that. Okay. So 25 is 1010. No? Okay. And then now 26. No. So let's compute this again using 25. We just have to lay it down because we'll use fractions later. No? So for 25, what will we have? So this is first, we'll remove this. Okay. So for 25, we'll have 116, and then we'll have a 9, so therefore we'll have an 8, and 0, 0, 1. Okay. So our 25 is 10101. What's the ones complement? Ones complement of 25. We'll just reverse this. This is 0, 0, 1, 1, 0. You follow? We flip the zeros to ones and the ones to zeros, and we retain the leading and trailing bases. No? So we add 1. Okay. What we'll have is 0, 0, 1, 1, 1. So this is the 2's complement of 25. Since we're just going to add, we'll just add 26 here. Right? Do you follow? It doesn't matter whether which comes first, because anyway, we're doing addition. So we'll just copy this. Okay. Do you follow? Okay. We'll insert because we need to have a place for the carry. Okay. 1 plus 0. Anyone? 1 plus 0 is 1. 1 plus 1 is a 0. Carry 1. Right? 1 plus 1 plus 0 is 1. Carry another carry 1. 1 plus 0 plus 1 is 0. Carry 1. This is a 0. And the last carry is 1. We discard the last carry. Okay. We discard this. Okay. Discard natin. Okay. So the answer is, actually that will be an indicator that the answer is positive. No? The last carry. No? (26 minus 25), may mali tayo, no? I'm sorry for that, no? Because this is 1 plus 1, this is a 0, no? Do you follow? 1 plus 1 is 0, carry 1. 1 plus 1 is a 0, carry 1. So our answer is 25 minus 26 is a 0, 0, 0, 0, 1. Okay? You follow? So this is our answer. 25 minus 26 is 1. Okay? Now let's have 26 minus 25. Do you follow? This is the second example. Wala na muna tayo dito, no? Kasi we're whole numbers anyway, no? We'll compute 25 minus 26. Okay? Okay. So anyway, we'll use 25 first. And then we'll put 26 here. Okay? Para madali na lang, no? So this will be 0, 1. Okay? That's 25. For 26, this will be 1, 0. Okay? Right? Do you follow? Okay. So once complement of 26, once complement of 26, we'll have 0, 0, 1, 0, 1. Remember that the trailing and leading zeros, the zeros to the left and zeros to the right are important. No? Plus 1. Okay. We'll have 1. This will be 0, carry 1. This will be 1. 0, 0. So this is the 2's complement of 26. You follow? This is how you should solve. No? So since this is the 2's complement of 26, we'll just add 25. Let's put in some spaces, some rows, because there will be carries. So where do we get 25? We'll just copy it here. Do you follow? Any questions so far, please chat me if you don't follow. No. Anyway, this is recorded. We'll just add. It doesn't matter which comes first because we just add anyway. No. This is yeah. 0 plus 1 is 1. 1 plus 0 is 1. Okay. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 0 is 1. The carry is a 0. Okay. The last carry is a 0. Therefore, it's a negative value. Do you follow? No? So this is negative value because the last carry is a 0. Now, if the last carry is a 1, it's a positive value. Remember, baligtad, no? Okay? Do you follow? So this is positive value. I'm sorry, negative value, no? Okay? Negative value. Okay? The last carry is a 0. Here, the last carry is a 1, so we have a positive value. Okay? Positive because the last carry is a 1. Okay? You follow? No? In here, this is a negative value because the last carry is a 0. Okay? Okay. Since this is a negative, how do we compute? How do we compute quickly for a negative, We know that this is a 2's complement form. Okay? How do we compute? We just assign them, since 1, this is a 1. The MSB is a 1, right? So we just assign a negative value, okay, to the MSB. Okay. Okay. So now we sum. Oh, the result is negative 1. Okay. Okay. Our answer is 1, 1, 1, 1, 1. That's in 2's complement. The equivalent in decimal is negative 1. Do you follow? Do you get my point? So take note now of the last carry. If the last carry is negative, that's a 0. If the last carry is positive, that's is 1, that's positive. Ibaligtad dito sa marking natin sa fixed point, no? Do you follow? Later, it's just converted into the correct form anyway. No? Any questions so far? Any questions? Okay. Okay. So these are the first two examples, no? First two examples of this, ano. Now we will have 11.25 minus 6.5, okay? We'll compute 11.25 minus 6.5. This time we are using a fraction. We'll just save this na lang siguro, no? And then for your benefit, I'll upload this, okay? For your benefit. No? Which place is this? So this binary fraction simple example. Okay, you follow? We'll name this as 26 minus 25. This is name 25 minus 26. This is 11.25 minus 6. Okay, do you follow? Do you follow? Maybe we can also have 6.5 minus 12.5 later, no? Any questions? Do we have time? Yes. So what we'll copy here is just this, no? The binary series. So we don't have to copy this from scratch. Okay, is correct? Yes, no? Tama pa rin tayo. So first we have 11.25. Okay, so we will unmark this. Okay. For 11.25 we can use 8. Okay, we're left with 3, so we cannot have 4. We can have 2. We can have 1. Okay. We can have 0. We can have 1. Okay, that's 11.25. Okay, and then we'll copy this. We'll have to compute 6.5. Okay, is this 6.5? Yeah. So this will be a 0. It's important that we'll have a 0 there because that's the most significant bit of 11.25. It's also starts at 8. No? You follow? 6.5. Okay. 6.5 is this is a 0. This is a 1. This is a 1. This is a 0. And this is a 1. Okay. Do you follow? Okay. So the ones complement 6.5 is what? 1, 0, 0, 1. Right? I just flip the zeros to ones and the ones to zeros. It's important we start here, not here, because this has no course equivalent also. Do you follow? Do you get my point? So add 1. Follow. Okay, so 1, this will become 1, 1, 0, 0. Okay. This is the 2's complement of 6.5. Okay. Do you follow? Any questions so far? So we will add 11.25. It doesn't matter because we're just doing addition. So 11.25, we'll just copy this. Bakit ano? So may mali tayo, no? I'm sorry. there's a mistake here. No? We'll go back from the start. Why? Because this is our most significant bit is here, 0.25. So we have to assign this as 0. Okay? Our least significant bit. Hanggang dito tayo. Do you follow? Do you get my point? We will make a mistake if we will not consider the least significant bit up to this point. Okay? It is here that we will add 1. Okay? This will become 1. This is a 0. This is a 1. 0, 0. We will know because they will have different, they will not match when you copy. Okay, we paste here. Okay. We'll insert two rows. Okay, you follow? Now we continue with the addition. 1 plus 1, it's a 0 with a carry of 1. Okay. 1 plus 0 is a 1. Okay. 1 plus 1, it's a 0 with a carry of 1. 1 plus 0 plus 1, it's a 0 with a carry of 1. Okay. 1 plus 0 plus 0, it's a 1. Okay. Okay. Dapat positive. Dapat ano tayo eh. 1 plus 1 is a 0. Okay. Carry of 1. So which means this is a positive value. Okay. Because the last carry. Okay. We'll discard the last carry. So the answer is what? Answer is 1, other 0, 1, 0, 0, 0. That's in two's complement form. Okay, so let's copy the places. Ito yon 0. And then we will add a 1, a 16 here. That's why this one is important. Okay, because it starts with a 0, we have 16. Okay, do you follow? Okay, do you follow? So we'll add a 1 here. Okay, and then what's this? Is that why did we do this? We are going to convert this to decimal. Okay, and to convert this to decimal, we check if the last most significant bit is a 0. If it's a 0, we extend it. We add it and 1 here, no? And do the normal conversion, which assigns a negative value to that place. Okay, you follow? Okay, can we sum this? Ay, mali tayo, no? I'm sorry, I don't think it applies, no? But let's just compute the since this is positive, no? Since this is positive, it doesn't apply for fractions, okay? Since this is positive, okay, we just compute this as it is, no? Okay, so this is a 4. Ano na lang, yeah, this is positive, so this is not in two's complement form. So that's why I had a mistake, no? I'm sorry, we do not have to use that because this is positive. So, which tells us that this result, this answer, is not in two's complement form. Do you follow? No? Do you follow? So this is our answer. It's not in two's complement form because the last carry is a 1, it's positive. So it doesn't apply. So what we'll do is just compute, no? Do you follow? No? So bakit may mali tayo dito, no? Because how much is 11.25 minus 6.25? $6.5. 4.75, no? Then this mali na. Okay. But yeah. I had an answer before, no? I had a correct answer before for this. This is 11.25. Okay. Are we correct, by the way, no? Nagkamali tayo, no? Okay, let me check my previous solution on this, no? I think I have, we have simple example. Andito, no? I have that example anyway. No? It's the same thing, no? I'm sorry. Mali. Okay. I have another example. Sample questions. Just that. Okay, open na yan, ano? I'm sorry, I don't have an example for fractions yet. Okay. I will review the whole process again and present you the correct answer. Anyway, you watch the video yourself. Okay. Any questions so far? You watch the video, I will review it. No, I'm still a little lost with the fractions, but I'm sure I have solved it before. I'm lost where I found that. No? However, there are examples that you can find in our regular class. No, any questions? I promise I will correct the mistake. No? So, for example, 2's complement of 83. How do you convert? Okay, you can 83. The next is 1 to 8, so 1 to 7. Right? 1 to 7 is the next. You can say 1 to 7 minus 83, 44. Do you follow? Or if you want to know, you just convert 83 and flips the ones to zeros and zeros to ones. Okay. So there are two examples here. You can subtract 83 from 1 to 7, 44 is the answer. That's the ones complement. Or you can convert 83 to binary, which is 101010011. You flip the ones to zeros, this is this. And if you compare, it's the same thing. Take note, no? Pareho lang sila, no? You follow? Complete, convert 2's complement. 44 is the 1's complement. And then you add 1. Okay? You add 1. 45, no? 44 plus 1, which is 45. You just convert this. So that's the 2's complement of 1 to 7. Diba? Because the 1's complement is 44, you add 1, it's 45. You just convert 45 to binary. That's the 2's complement. Okay. Or you can do the flipping and add 1, it will still have the same. Do you follow? No? Subtract 53 from 97. So here it is. No. First we have 97. Convert this. Okay, this 64 plus 32 plus 1. And then we convert the 2's complement to 53. This 53. We add 1. Okay, this is the 2's complement. And then we add the 2's complement right away. Okay, the answer is this. And then 1 is the last carry, which means the answer is positive. Okay, do you follow? So checking the answer, we have the correct answer, which is 44. Okay. Any questions? You study this yourself, no? 97, subtract 97 to 53. This time baliktad, no? So this is the binary of 53. That's 32 plus 16 plus 4 plus 1. That's 53. And compute the 2's complement of 97. So this is 97. And then you add 1. So this is 97. You just add them together anyway, no? Because it's now in 2's complement. So the answer is negative 44. Take note that the last value is a 0. So it means that this is a negative number. Okay, so to convert this, we discard this anyway. We assign a negative value of 64 to this. So the last, and then you compute. The resulting answer is negative 44. Okay, so that's correct. Convert to 2's complement this number to decimal. Okay, this is a 2's complement number. So we know that this is 1. So we'll have we'll assign negative 16 here, and then we just sum. That's 3. Okay, and then convert the following to 2's complement number. So 0, 0, no? So we extend it to 1 and assign it a negative value. So this is 103. That's what we get. Okay. Or you can convert the traditional way. Anyway, this solution is already in Degler, no? Okay. This is an example on conversion. It's in Degler. You can download this. No? And then we will solve exercises, the sample quiz, binary subtraction sample questions. Okay. Where is it? Ito, no? Okay. Okay. It's here in the test. Okay. I'm going to explain that in the test. Okay. Any questions so far? So you do the test here. I will explain the fractions later. Anyway, the test does not involve fractions yet. Any questions so far? So you do this test now. This is not graded, but this will be part of the next formative test, which will be on September 17. Okay. So I will not introduce a new topic anymore. That will be our final topic. I will review the subtraction with fractions next meeting and answer the exercise. Okay. Any questions so far? Okay, I'm sorry for the disturbances now, but yeah. Okay. I'll upload this recording. Now I already have uploaded a previous version from the other class. You can also take a look at that. No? Any questions so far? Okay. So thanks everyone for coming. No. Okay. Arkan Ramirez have been marked present. Everyone, thank you very much. We'll end the session now.
Thank you po, sir.
Thank you.
Thank you, sir.
Thank you.